All right, in this video, we'll be taking a look at ohm meters and diode check settings and why we don't use ohm meters to test things like diodes and transistors. And we'll start by checking this component here. This is called a diode trio. It was found in GM alternators in the late 70s and early 80s primarily. And what this consists of are 3 diodes in one. Now on the left here, you'll see 3 leads sticking out here. Those are the anodes, the positive side of the diodes, all separate. And on the right here are all the negative side, the cathode sides of the 3 diodes, all tied into one. So that's the configuration of this diode trio. So what I'll do is actually show you the testing of this diode trio both ways, forward biased and negative or reverse bias. And I will show you why we don't use the ohm meter setting. It will provide faulty numbers, and it doesn't do a lot of good. In many cases, will actually show a diode that is actually good. It will show it as bad. So the first thing we'll do is spin this to our ohm meter setting. And what you always want to do, right, is make sure, verify that your meter is doing what you think it should. So in the ohm meter setting, you'll see 1.0 or 1 blank, or in this particular meter, it's 0.FL. This is basically an overload. It's infinite resistance. The leads are not connected together, and we spoke about in class how the internal operation of ohm meters work. So what you want to do to check this is touch the leads together. You should get extremely close to 0 ohms. That's very close. 0.12 ohms, that's negligible. All right, so we know this ohm meter is set up right and working. So the first thing we'll do is we'll check the forward bias. So the cathode gets the negative, and the anode we want to check. Now you would think that this would be show continuity, show continuity, show continuity, because that is the forward bias operation. And if we look, you'll see you'll get something extremely large, 1.64 mega ohms. That's nearly an open circuit. You'll get the same on all 3, fairly close, an extremely high resistance. And when we switch it around, you should get that infinite, because now we're checking it in the reverse bias. Now you do get infinite there. So in this particular meter, and not all meters will operate exactly this way, but they all have the same flavor. So this particular meter, you do get a reading when you forward bias, but it's not at all helpful. And if I asked you if 1.6 mega ohms was a high resistance or not, I think we'd all agree that it's extremely high. So it's not really providing a whole lot of value to you. And depending on the meter, that might show the same on the forward bias as it does on the negative, meaning wide open. And that's not going to give you any information at all. So what I want to do is show you why we use the diode check setting. So you can see up here, all meters, that shows a diode check setting there. You see it on the display here. So let's just connect it to and do our first check with the forward bias. And you see here, it's 0.51. And now notice, like I had mentioned in class, we're no longer reading amperage, we're reading voltage. That's the voltage it takes to get current to begin to flow through that diode. Right? This push of this PN junction, the closing of the PN junction, does come at a small cost, a small amount of voltage, and that's the amount that it takes to forward bias a diode. And we know from class what our specifications are. That's 0.51, 0.517, 0.514. Now what we have to do is switch this around. So I'll just make our lives easy, and I'll use these alligator clips. So now we're checking it in the reverse bias, and it should be infinite. It should stay like that, as in we cannot bridge that PN junction. Right? And you can see all 3 leads are tested, and they all show open. This diode trio is working how it is supposed to. It properly checks the diode. And again, I want to get back to this, the forward bias. That voltage, again, tells you what it takes to get current to flow through that diode. And the amount of voltage, again, I'll let you look that up in the specifications. It was on our last theory class, or at least the one prior to the one that I'm videoing here. And it actually tells you what that diode is made of, either silicon or germanium in most cases. Now, this is actually so extremely close, you could argue you don't know which one, but I do happen to know that these are silicon diodes.